Okay, today we're going to learn how to simplify radicals. We need to start by reviewing the perfect squares. So when I say something's a perfect square, that means it's something that can be simplified. It's a square that can be simplified perfectly because it was two numbers multiplied together to start with. So that would be like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Now, by no means is that the end of the perfect squares. I could continue from there, but those are the ones that I want you to have memorized. Those are the ones I think you should know kind of for the rest of your life. But those are perfect squares. Those are numbers you'll want to look for. Now, what is the perfect square of these? Well, if I wanted to take the square root of each one of these, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. 7, 8, 9, 10, 11, and 12. And again, that's because that's 12 squared is 144. So the square root of 144 is 12. So you should really know and understand those pairs. Now, what we're talking about today is how to simplify something that is not a perfect square. So to do that, we want to first start by learning how to simplify expressions, and then we're going to use that same concept to apply it to when things have a product of perfect squares, so multiplying two things that are perfect squares. Okay, example number 1. If I have the square root of 2 over 72, and I am wanting to simplify that, I want to start by doing what's inside. Sometimes, always, I treat what's under a radical like a parenthesis group. And so if I was using PEMDAS, I would do what's under there first and try to simplify if I can before I start dealing with the square root. So if I do 2 divide 72, I get 1 over 36. And then there's a rule about square roots that I can separate this into square root of 1 over square root of 36. I can separate the top from the bottom. And then the square root of 1 is 1, and the square root of 36 is 6. So my answer is 1/6. Let's try some more. Example 2. If I have two square roots being added together, so the square root of 3 squared plus 4 squared. Again, I start with what's underneath, so 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25, and the square root of 25 is 5. Seems simple enough, I suppose. Example 3, if I have the square root of 256 over 4, this one kind of mirrors example 1. If I divide 256 by 4, I get the square root of 64. And that's just 8. Let's try one more. If I do example 4, that would be the square root of 40 plus 9, and that would be the square root of 49, which we know to be 7. So I can kind of simplify what's underneath first if I have some options there, and then I can use those rules like separating the top and the bottom or adding things together and then getting the square root. So that should be kind of a review for you. What about if there's a product? So let's call that initial section part A. Let's call this part B, if there's a product. I'm going to give you some steps. The number 1 is to use a factor tree. We've talked about those before. Step 2 is to pick the pairs. And I mean pairs like pairs of shoes, but if it will help you, you can think tree and then pairs, as in 2, right? Like a pear tree. Get it? Step 3, is that the pairs go outside of the radical sign and the singles stay in. I always like to think of that as like a pair of shoes. If you can't find both shoes in the pair, you don't usually wear them out of the closet. So if it's a single, it stays in. Okay, let's look at some examples. Number 5, the square root of 18. Okay, if I go ahead and make a factor tree, some things that multiply to 18, the first one that comes to my mind is 9 times 2. You could also do 3 and 6 and break it down. So guys, there is no real right way to go about factoring. If it is a factor, you can always factor it all the way down from any beginning point. To factor 9, I get 3 times 3. All of these are now prime numbers, 3, 3, and 2. So I'm going to pick the pairs, which are the set of 3s. 1 from the pair goes outside. So 3 and 3, one of those would be 3. And then the single, the 2, stays on the inside. And so I have simplified this. If it'll help you to think of it this way, what I really did was I said, well, 18 is like saying the square root of 9 and the square root of 2, because 9 times 2 is 18. The square root of 9 is 3, and the square root of 2 stays the square root of 2 because I can't simplify that. I'm just going to stick with this pairs way to show you, but this way is another great way to do it. The reason I favor this one over this one is on this one you'll have to be able to look for just the perfect squares, whereas this one they will automatically fall out. Let's use some more examples. The square root of 128. Okay, 128. 2 times 64, maybe? And 64 is 8 times 8. And I could stop there, guys, because I've already got a pair. I'm going to keep going just for the sake of argument, just to kind of show you what that would look like. So 8 would be 2 times 4. 4 would be 2 times 2. 8 would be 4 times 2. And 4 would be 2 times 2. And if I do my pairs, I've got a pair here. I've got a pair here. I've got a pair here. And I have a single here. Now, if I had paired these two, these two, these two, there'd be a single over here. It doesn't really matter the order necessarily. I have 3 sets of 2 that are pairs that go on the outside. So I'm going to take 1 from each group and multiply it. That'd be 2 times 2, which is 4, times 2, which is 8. So 8 goes on the outside, and now I'm done with this section, and the square root of 2 goes on the inside. If I stick to this idea again, if I started with 2 and 64, that was kind of lucky. That would be like doing the square root of 64 times the square root of 2. Square root of 64 is 8, and that's where that's coming out of. Let's look at one more example, number 7. If I have the square root of 5 over 9. Okay, now, I don't know anything about 5 over 9. There's nothing I can do to reduce it. There's nothing that I can do to multiply that will really help. So instead, I'm going to use my ideas from before, and I'm going to separate the square root of 5 over the square root of 9. Because I know the square root of 9 is 3. There is nothing I can do to the square root of 5, so I'm going to stop there. And again, it is okay to leave a square root in the answer. We just want it to be simplified. That's our lesson for today. Your assignment is page 808, and it's numbers 5 to 19. Actually, I think I changed that, so let me go back. Sorry. The assignment is a half sheet for you to practice on. So, good luck. Let me know if you have questions.